Alright, in this video we're going to take a look at the 6 trig ratios for 30, 60, 90 triangles. In particular, the 6 trig ratios for the 60 degree and 30 degree angles. In the next section we'll take a look at how to find them for the 90 degree angle, but for this one we're going to take a look at 30 and 60. So we create a 30, 60, 90 triangle by drawing an altitude inside of an equilateral triangle. So a couple things from geometry class. Number one, an equilateral triangle has all three sides the same length, and all three angles are 60 degrees each. And when we draw an altitude, a few things happen. First up, the altitude is perpendicular to the side that it intersects. So the altitude is going to make a right angle with that side. Second, it's going to cut this side that it hits in half. It's going to bisect it. So this piece and this piece are both equal if the altitude is drawn in an equilateral triangle. And lastly, it's also, in addition to bisecting this side that it hits and cutting it in half, it's also going to cut the angle in half that it was drawn from. So it bisects the angle it was drawn from. In this case, each one's going to be 30. So this is where we get the namesake 30, 60, 90 triangle. So again, the altitude is going to bisect one of the sides. And while we could use side lengths of 1 in our equilateral triangle, if we do that, and there's nothing wrong with it, we're going to have a half here and a half here. And I know how people feel about fractions, so I'll avoid them for you. So instead of using a side length of 1, since we got to cut this bottom side in half, let's use a side length of 2 just to avoid having fractions to deal with. Although again, there's nothing wrong with using a side length of 1. So when we do that, we got a length of 2 and then a 1, and then 2 for the other side of the triangle. Well, looking at this triangle on the left here, we have these two smaller right triangles here on the left and right. So focusing on the triangle on the left, we want to be able to come up with a representation for our altitude. And we know the hypotenuse and we know one of the sides of the right triangle, so hopefully you're thinking Pythagorean theorem, which we could do something like a squared plus 1 squared equals 2 squared, or a squared plus 1 is 4. If we subtract 1 from both sides, we get a squared is 3. So a for altitude, I guess. A squared is 3. That means our altitude, our height of our triangle, is going to be the square root of 3. So notice opposite the right angle is 2. It's the longest side in a right triangle. Opposite 30 degrees is 1. That's going to be the shortest side in this triangle. Square root of 3 is about 1.73. So 1.73 is in between 1 and 2. Just like 60 degrees is in between 30 and 90. So a nice concept from geometry class that could help you out in this section is the bigger the angle, the longer the side opposite that angle, and vice versa. So just to make sure that we have the sides labeled properly, opposite 30 is the shortest one, opposite the right angle, the hypotenuse is 2, is the longest, 60 degrees is in between, and square root of 3 is in between 1 and 2. So example 4, we're going to take a look at the 6 trig ratios for the 60 degree angle here. And then in example 5, we'll look at the 30 degree angle. But in the 60 degree angle, our hypotenuse is 2, our opposite side is the square root of 3, and then our adjacent side is 1. So the sine of 60 degrees is opposite square root of 3 over hypotenuse 2, or square root of 3 over 2. The cosine of 60 degrees is adjacent of 1 over hypotenuse of 2, or 1/2. And tangent of 60 degrees, opposite square root of 3 over adjacent 1, we get square root of 3 divided by 1, or square root of 3. And these would be the same ratios here if instead of 60 degrees, we use their radian equivalent pi over 3. So the sine of pi over 3 is square root of 3 over 2, and tangent of pi over 3 is also square root of 3. So it won't change if we switch over from degrees to radians using the same equivalent measurement. All right, now the reciprocals, cosecant, secant, and cotangent. We have cosecant of 60 is hypotenuse over opposite, or 2 over the square root of 3. And remember, we can't leave square roots in denominators, so we need to rationalize this. Easiest way is to multiply both numerator and denominator by the square root of 3. So doing that, we get 2 times the square root of 3 is just 2 square root of 3 over square root of 3 times square root of 3 is square root of 9, which is 3. So cosecant of 60 degrees, 2 square root of 3 over 3. Secant of 60 degrees, much easier. Hypotenuse 2 over adjacent 1, 2 over 1 is 2. Or take the reciprocal of cosine of 60 degrees. Finally, cotangent of 60 degrees is adjacent 1 over opposite square root of 3. And if we rationalize this denominator the same way we did cosecant of 60 here, we'll get 1 times the square root of 3 is the square root of 3. And then square root of 3 times square root of 3 is square root of 9, which is just 3. So cotangent of 60 degrees is the square root of 3 over 3. All right, so now we're just going to knock this triangle over and look at 30 degrees on the 6 trig ratios for 30 degrees. Notice when we do that, our hypotenuse is still 2, but the opposite side of 30 degrees is 1, and the adjacent side is now the square root of 3. So when we switched over from 60 to 30, our opposites and adjacents traded places as well. So we're going to notice a lot of similar answers to what we had in the last example. So let's go with sine of 30 degrees, opposite 1 over hypotenuse 2 is 1/2. That was the answer we got for cosine of 60 degrees. But remember, switching the angles switches our opposites and adjacents. So we're going to see a lot of those same answers that we did in the last example. Cosine of 30 degrees, adjacent square root of 3 over hypotenuse 2. That was our sine of 60 degrees in the last example. And finally, tangent of 30 degrees, opposite 1 over adjacent square root of 3. Well, that was what we got for cotangent of 60 degrees, and that rationalized to square root of 3 over 3. So because we've already done that work, we can use that work to speed up our answers in this example. All right, finally, the cosecant of 30 degrees, hypotenuse 2 over opposite 1, 2 over 1 is 2. Our secant of 30 degrees, hypotenuse 2 over square root of 3, and that's what we saw for the cosecant of 60 degrees, so let's just use that answer for how we rationalized it. 2 over the square root of 3 is 2 square root of 3 over 3. And finally, cotangent of 30 degrees, adjacent square root of 3 over opposite 1, square root of 3 over 1 is square root of 3. And again, by switching our angles, we switch our opposites and adjacents. So our sine of 30 was equal to our cosine of 60. Tangent of 30 was equal to cotangent of 60. Our secant of 30 that we got here was equal to our cosecant of 60. So notice we repeat a lot of these functions just by either putting the word co or the prefix co in front of it, like sine and cosine, tangent and cotangent, or removing it, like cosecant and secant. They're called co-functions because of that relationship, which we'll get into a little bit later, but for right now, just keep in mind that when you switch your angles perspective here, you switch your opposites and adjacents, so that's the effect that it's going to have on your answers. All right, that about does it for this video. In the next section, we're going to take a look at putting the 45, 45, 90, and 30, 60, 90 triangles in the coordinate plane and being able to get answers that are negative and 0 and some undefineds as well. So I'll see you then.